Hello students, welcome to series of lectures on digital speech processing. So in this video you will be able to learn spectral subtraction technique for improving the quality of the speech signal. In the previous video you have seen that the introduction part to the speech enhancement model, and then the nature of interfering sounds. Okay, that is stationary noise, non-stationary noise. Okay, so that noises which are interfere with the speech signal. Okay, and now in this video we are able to apply one technique. Okay, this is a DSP processing technique. We are going to be seeing the output should be the enhanced speech. Okay, so let's get started. So on completion of this lecture you will be able to analyze the spectral subtraction technique for enhancing the speech signal. So this is the introduction part. Speech enhancement aims to improve the quality of the speech, and then reducing the erratic noise in the digital telephony, reduction of interfering backgrounds and speakers for the hearing impact, and then to increase the intelligibility, that is understanding of the maximum words which are spoken by the speaker. So this is the block diagram of the speech enhancement. So these many things that we need to focus. So especially the background noise, and when you record any kind of a speech signal, then it has to be taken under background noise. Then it's a lot of impact to the listener. So the listener will not be able to get the words which are spoken by the speaker. So here, so we need to address the problem, so not only enhancing the quality of the signal, but the listener has to understand what is the word is there in the sentence which are spoken by the speaker. That is called as an intelligibility. Okay, so that is the main goal of the speech enhancement. The goal of speech enhancement is to increase the intelligibility of the speech and perceptual quality. Okay, so these two things are very important for us to develop any kind of technique for enhancing the speech signal. Alright, now let us put our concentration towards the spectral subtraction method. Alright, these are the several steps actually we need to follow. So spectral subtraction is a widely used speech enhancement technique that is based on the idea. The name itself indicates we need to subtract. Okay, so what we need to subtract? Subtracting a noise estimate from the noisy speech signal in the spectral domain. Okay, so normally in the spectral domain, that means when you apply Fourier transform, that is fast Fourier transform, or you can apply DFT, discrete Fourier transform, and you'll be getting the spectrometry out of frequency domain representation. So in the spectral domain, we are subtracting the noise estimate from the noisy speech. That's all. So the spectral subtraction algorithm works in the following steps. So the first step is that the short time Fourier transform is applied to the noisy speech signal to obtain its frequency domain representation. And the second is that a noise estimate is obtained by averaging the power spectrum of the noisy speech signal over frames. Because when you apply the windowing technique and the framing technique to the actual speech signal that we have recorded, okay, so we'll be getting the frames. Those are nothing but the short time Fourier transform signal. So the third step is that the noise estimate is subtracted from the power spectrum of the noisy speech signal. And the last step is that an inverse STFT is applied to the enhanced speech spectrum to obtain the time domain representation. So these four steps are very, very important for us to understand the method of spectral subtraction. The process is very simple. We need to subtract the noise estimate from the noisy speech signal in the frequency domain. Alright, so this is the block diagram of the spectral subtraction. It's very simple. So noisy speech is there, and we will be applying the fast Fourier transform. Okay, when we see the noisy speech, so here the process is already involved. What is the process? What process has been already involved? The framing and then windowing to the actual speech that we have already recorded. Okay, and that you are going to be having some background noise. We have recorded the speech signal under background noise. Then that we are calling as the noisy speech. That noisy speech I am taking as an input to the FFT. Okay, and you'll be getting the output should be the coefficients, the filter coefficients you'll be getting, and here the averaging, the squaring the spectrum that you will be taking, and this is a noise estimation. So from the noise estimation, that will be directly taken here, and we need to subtract the noise estimation from the noisy speech signal and the spectral domain. Okay, so you'll be getting the subtraction, the spectral subtraction will be getting, and that can be given to the inverse fast Fourier transform, and you'll be getting the enhanced speech. So this is a process of spectral subtraction. There's 4 steps, whatever that we have already seen in the previous slide. We will be understanding this block diagram with respect to those steps only. Now, so this is a block diagram for 2 microphones. Okay, so earlier we have taken only single microphone. Now when you record the voices, one is the noise is directly taken from the secondary signal, and the noise speech is the primary signal. The 2 signals from the 2 microphones you are recording and you are giving to the Fourier transform, and you will be getting the amplitude and then phase, then digital filter, and you are subtracting from there. Okay, after subtracting, the output of the subtraction will be given to the inverse Fourier transform, and you will be getting the output speech. Okay, so this output speech is nothing but the enhanced speech you will be getting. Okay, that's all. The process is very simple. Thank you, students. Thank you for watching this video.